All right, this is it. Section 9.5, lattice energy, the last section for chapter number 9. Introduction to lattice energy. The formation of solid KCl from its elements is highly exothermic. Solid potassium plus 1/2 Cl2 gas yields KCl solid. That's got a delta H not F. Heat of formation of negative 437 kilojoules per mole. However, the sum of the ionization energy for potassium is positive 419 kilojoules per mole, and the electron affinity for chloride is negative 349. And so that difference would be positive 70 kilojoules per mole. How? What? Well, ionization energy and electron affinity describe energy changes for particles in the gaseous phase, where there are few interactions between particles. In the solid phase, there are many interactions between oppositely charged particles as the lattice forms. Okay, so this tells us the solid and the gas, rather than gas and gas mixing with one another. So to reconcile that, well, the sum of the interactions between oppositely charged particles in the solid is the lattice energy, delta H naught sub L. That's negative 717 kilojoules per mole when we're going from gaseous K plus to Cl minus yields KCl solid. The lattice energy is the energy released when gas phase ions are converted to a solid compound. Okay, so that's good and well and everything like that, but if only there was a way we could look at all of this information. Well, lo and behold, there is. The steps to determine lattice energy of KCl. The reverse of the enthalpy of the formation of KCl, KCl going to basically breaking down into the two components. That is going to be positive 437 kilojoules per mole. Now what we need to do is we need to look at the conversion of Ks to Kg. That sublimation is positive 89 kilojoules per mole. Now step 3 is where we look at the actual ionization of that gaseous potassium. Well, that is going to be positive 418 kilojoules per mole. The formation of Cl gas from Cl2 gas, well, we've got bond energy that's being broken there, in which case that's positive 122 kilojoules per mole. Then we need to look at the addition of an electron to chlorine gas to form Cl minus gas. That electron affinity is negative 349 kilojoules per mole. So we can use all of that data and plug it in here and get, well, all of those different H naught values and all those numbers, combine them together to get our delta H naught L of negative 717 kilojoules per mole. So our lattice energy takes into consideration the heat of formation, the heat of sublimation, the bond energy, the ionization energy, and the electron affinity in order to get us that total value there. All right, I hope this is helpful. That's chapter 9. Chapter 9 is kind of well, it's a handful of trends and understanding some concepts, building off of chapter 8. You could make the case that chapter 9, it's not a whole chapter, it's parts. But I'm not going to make that case. So I would look at this as a lighter load of a chapter. All right, you got this. I'll see you in chapter 10.